In this problem, the voltage across a 2 ohm resistor is given by the waveform below. Find the average power absorbed by the resistor. This is going to require us to determine the RMS value of that waveform. So the RMS is calculated as 1 over t, integral from 0 to t, v squared of x dx. Okay, so we've got to go in there and take the voltage waveform and square it, and then we're going to integrate it over a period and then divide by the period. Now the first thing is we obviously need is the period. If we look, this waveform repeats every 10 seconds. So we have 2 periods of our waveform shown. You see t is equal to 10 seconds. And the other thing is, if we look at, we need an expression for the voltage over the interval from 0 to 2 seconds. So I think if you look, we can use the equation of a straight line, but V of t is equal to minus 5t volts for t between 0 and 2 seconds. Okay. So now it looks like we're ready to integrate. So the RMS, we have a period of 10. Now we're going to go in and we're going to integrate 0 to 2 of minus 5t squared dt plus the integral from 2 to 4 of minus 10 squared dt plus the integral from 5 to 10 of 10 squared dt. So then we have 1/10, and we have the integral from 0 to 2 of 25t squared dt plus the integral from 2 to 4 of 100 dt plus the integral from 5 to 10 of 100 dt. Now, we'll go ahead and write this as 0.1. So now we have 25 over 3 t cubed, evaluate from 0 to 3, plus 100t, evaluate from 2 to 4, plus 100t, evaluated from 5 to 10. So now we have 0.1. This okay, should be a 2 there. This should be 25 over 3 times 2 cubed plus 100 times 4 minus 2 plus 100 times 10 minus 5. And if we go through and calculate, the RMS value of the voltage is 8.756 volts. Now, for our resistor then, the average power then is VRMS squared over 2. So we have 8.756 squared divided by 2, which is 38.33 watts.